Are you into trig yet?
Yeah, I guess you could say that. Limits and trigonomic functions.
Oh, so actually you've had trig. So
Yes.
you're into pre-calc. Uh,
Mm-hmm.
limits is kind of what separates algebra, geometry, and trig from calculus. That's the difference. Every calculus class starts with limits because you haven't had limits prior to calculus. Um, so limits are kind of a completely new thing for you. All right, what kind of limit problems are they starting you out with?
Graphed ones.
Okay, you're probably gonna
I
need to
can
send
send
me
you a
pictures.
picture.
You send
Yep, I can send you a
pictures
picture.
online? Okay, there it is. Which one should we start with?
The
Upper
top
left
left
or
one.
upper right? Upper left?
Yes.
Okay. All right. Starting with 1.
Yes.
Okay. Is that a continuous function?
Yes, because I don't have to pick up the pencil, right?
Actually, you do. Notice that
Oh,
when x is equal to 2, you have to pick up the pencil.
yeah, there's a hole. Never mind.
Yeah. So, and that is the layman's definition of continuity, is do you have to pick up the pencil or not? If you have to pick it up, then it's not continuous. How about number 2?
Um, I believe that's continuous.
Nope, I got to pick up the pencil when I get to x equal 3.
Even at the end, it counts.
Uh-huh.
Okay.
Okay. And number 3.
This one is continuous as there isn't a hole.
That's continuous, correct. I do not have to pick up the pencil to draw it from the left to the right. And number 4?
It's not continuous.
Okay. Number 5 through 10, it says refer to this piecewise function. So each one of these is kind of a piecewise function, 1 through 4. So this is just one that has 5 parts to it. That's all. So question 5. I can't quite see this entire curve. You chopped it off a little bit at the bottom. I can't really tell what it does. Can you quickly send me another picture that shows the whole curve?
Yes. One moment.
Okay. It's hard to do these problems if you can't see the whole thing.
Okay.
Especially when the very first question says, does f of minus 1 exist? Well,
And it's not there.
I can't see where minus 1 is on the y-axis. So.
Sent it.
All right. I love technology.
Yeah.
Man, this wouldn't have been possible 10 years ago to be able to
Yeah.
do online like this, not as efficiently as we're able to do it. Okay. So now what is f of minus 1 equal to?
Um,
Just looking at
it
the graph.
does not exist.
Well, look at the graph. Is there a y value when x is minus 1?
X squared minus 1.
Well, just look at the graph. Don't look at the function necessarily.
Oh, so it'd be 0. Okay.
So it does exist. In other words, as long as there is a point right there at x equal minus 1, y equals 0, then x of minus 1 does exist. Okay. Let me figure out how to do this here. Now I can't see the problem 5, so I got to go back to the original. No problem. So B says, this is weird. Oh, I see. B says, sometimes I hate Windows. I really do. I really hate Windows. I can't even read B. Yes, I can. Okay. Does the limit as x approaches minus 1 from the plus side exist?
Yes.
Okay, I can see it. And yeah, limits that approach from either the right or the left almost always exist. The ones that don't exist are the ones that have different values when you approach from the left and the right. So what is this limit as we approach from the right? As we approach 1 from the right, what is that limit?
It looks like a
The
2.
way you do it is just put your pencil on the graph and start approaching that point from the right. And what are we headed towards? We're headed towards a y value of 2. That's the limit. You see why?
Yes, because directly over 1.
What if we approach 1 from the left? What's the limit?
2.
Since they're both the same, then
2.
what's the limit of this function as we approach 1?
It would be 2.
What's the value of the function at 1? Pointing at it right there.
I thought it would be 2 because left and right hand limits are equal.
Yeah, but that's not true. In other words, for a limit to exist, its limit from the left has to be equal to its limit from the right. But what doesn't have to be true is that the value at that point does not have to be its limit. In other words, f of 1 is actually 1.
Okay.
But the limit as x approaches 1 is actually 2. In other words, this seems like a contradiction, but it's not. Is all you need for a limit to exist is that it be the same when you approach it from the left as you approach it from the right. And in this case, they're both approaching this number y equal 2. So that's the limit, regardless of what the function's value is at 1. This is a piecewise function whose value at 1, there's a big jump gap there between 1 and either side of 1. And that's what the next question is going to be. So, oh, I'm sorry, we were supposed to be approaching minus 1 from the right. Hold on a minute here. Let me figure out how to get both of these on my screen at one time. I got to go down to your second email and open it up. All right, now I can get them both on my screen. So I was actually reading question 5 wrong. Question 5 was, I can get it on my screen. Do you know how to eliminate this top? How do I eliminate that? Because it's covering up part of my answer, part of my text. How
I have no idea, honestly.
expert in Windows 10 are you? I'm relatively new to it, but I can just barely see question 5b. What is the limit as we approach minus 1? I originally thought that said 1. So minus 1 from the right. No, hold on.
0.
What's B say? Minus 1 from the left or minus 1 from the right?
Minus 1 from the right.
That's what I thought it says, but doesn't C say the same thing? Oh, no, you're right. The limit is 0 as we approach minus 1 from the right. In other words, we hop on the function and just move our pencil to that point, and that's 0. Okay, so number C says, does the limit as we approach minus 1 from the right, is it the same as f of minus 1? What's f of minus 1?
That would be 0.
So it's the same.
Yes.
Okay. Is f continuous at x equal minus 1?
Yes, because it's a point.
Yeah. In other words, it doesn't go to the left of that, but it doesn't need to. I can draw it to minus 1 and stop. All right.
Okay.
Now, number 6 is where it talks about, does f of 1 exist? Well, can you see that, or do I need to, let me blow it up just a little bit?
I can see it. I have it on my iPad too.
Okay. Does f of 1 exist?
Yes.
What is it?
It's 2. Left and right hand limits are equal to 2.
Those are the limits as we approach 1 from the right and the left. But what is f of 1? In other words, if you go up, if you look at the graph or go up to the functions, when x is 1, f of 1 is 1. In other words, it's this dot right there. So
now I see.
f of 1 exists, but it's not 2. It's 1.
Now I see my error.
Okay. Now, 6b says, does the limit exist? And the only thing that requires is the limit from the right be the same as the limit from the left. Are they the same?
Yes.
They are. So the limit does exist. And the limit is actually 2, not 1. In other words, the limit is different than the value at that point. And that's what seems paradoxical to people, is that they do not have to be the same. My limit as I approach 1 can be a different number than my evaluation at 1. So 6b is yes. 6c, does the limit of the function as we approach 1 equal to f of 1? What was the limit as we approached 1?
Actually, it would be no, it's not equal.
Right, because the limit as we approached 1 was 2.
Yes.
And f of 1 is 1. So no, they're not equal. Is it continuous at 1?
It doesn't have anything else touching it, but
Well, you'd have to pick up your pencil to draw it, right?
yeah.
So it's not continuous. And there is a more mathematical definition of continuity. The layman's definition is you got to pick up your pencil to draw it. But there is a very clear math definition of it also. And here's what it is. Three things have to be true. The limit from the left has to equal the limit from the right, and the value at that number has to be the same thing. So you got to get a yes to all three things in order for it to be continuous. So this is not continuous because f of 1 does not equal to the limit as x approaches 1. That proves non-continuity right away. And you can also see it from looking at the graph. I could not draw this function without picking up my pencil at x equal 1.
True.
All right, number 7. Is the function defined at x equal 2?
Looks like it's 0.
It's not actually defined. If you go up and look at each of your five, you look at your 5 functions, notice that x equal 2 is not in the domain. In other words, I've got the fourth one is x is between 1 and 2, and the fifth one, x is between 2 and 3, but there's no place where x is equal to 2. So f of 2 is not defined. So is x continuous at 2?
No, it isn't.
Okay, number 8. At what values of x is f continuous? Well, the easiest way to answer this is to say where it isn't continuous. In other words, from -1 to 3, we have numerous places where it's not continuous. So I could say it's continuous from -1 to 3 except where?
0, -1.
No, -1, it's continuous.
I mean, not -1. Yeah, 0. I meant 0. I was
0 is correct. And then 1, it's not continuous.
1, 2, and 3.
Correct. And it's unusual for a function to end with an open dot like that, but that means it's not continuous. I could say, what is the limit as we approach 3 from the left?
It would be 0.
Yeah. And there is no approaching 3 from the right. So I might be tempted to say that it's continuous at 3, but for it to be continuous, f of 3 would have to be defined. And f of 3 is not defined. That is not in the domain. Therefore, it's not continuous at 3 either. So number 9, what value should be assigned to f of 2 to make the extended function continuous at 2? That's a complicated way of asking something, but what would I have to do? As long as I made it, if I turn this hole at 2 into a closed dot, then it would be continuous, right?
Yes.
Because I could draw it without lifting my pencil. So the only thing I would have to do is make f of 2 defined. And it would have to be equal to 0. In other words, if I make that a closed dot, then f of 2 is equal to 0, and I have continuity. From this point here, I can draw it to this point here without lifting my pencil.
Yes.
Number 10. To what new value should f of 1 be changed to remove the discontinuity?
To 2.
Yeah. In other words, if I made this middle part of the piecewise function up here, if I said when x was equal to 1, f of x was equal to 2, that would move that closed dot to this open dot, and then I would have continuity. In other words, I would have it because the limit from the left equals the limit from the right equals the function evaluated at that point. All three of those have to be true for it to be continuous.
Okay.
Now, let me close that out. I think we're done with that function. Let me put this up. Are we going on to 11?
Yes, that works.
Okay.
Actually, skip 11. We could just do 13.
All right. Still trying to figure out how to get this thing. There we go. All right. When you're trying to figure out, when they give you a function and you're trying to figure out where it's continuous, the first thing you want to look for, are there any asymptotes? In other words, this function, are there any places where we have problems evaluating the function? Well, what's the first thing in math that you cannot do?
Divide with a negative.
Divide by 0. You cannot divide by 0.
Okay.
So when x is equal to 2, I'm dividing by 0. Cannot do that. So it cannot be continuous there. In other words, whenever you're dividing by 0, you end up with a vertical asymptote. Let me give you a little simpler function here to show you that. If my function is 1 over x, well, I have a vertical asymptote there, and I have a horizontal asymptote there. Although my pen doesn't want to work. What the heck? What happened? Just a second. Wow. It made that whole page disappear. Just a second. It will come back up in a moment. Okay. If I have let me unplug my drawing tablet and plug it back in again. Hold on.
Okay.
Now I should be able to pull that up. If I have y, wow. Weird. Well, that's really weird. Well, back to my y equal 1 over x. That's going to graph like this. Hyperbolic. And it has a vertical asymptote here and a horizontal asymptote there. So where is that not continuous?
At 0. Wait, yeah.
Yeah, make sure you define these in terms of x and y. In other words, I'm not sure that it's sufficient to say that it's not continuous at 0. It's not continuous at x equals 0.
Okay.
Because I can't draw that function without picking up my pencil when I get to x equals 0. Okay, so back to your function that they gave you. Let me erase some of this other stuff. And my eraser isn't working. Wow. Hope I don't have to get a new drawing tablet. In other words, the only thing we have to figure out as to where this is not continuous is wherever I have a vertical asymptote, which is wherever you're dividing by 0. So where is this not continuous?
At 0 to I'm trying to think of how I would say it.
What value of x gives this problem problems?
2.
That's where it's not continuous. It cannot be continuous whenever you're dividing by 0 because you're going to have a vertical asymptote. And there's no way to get across a vertical asymptote without lifting up your pencil. So the only place is x equal 2 gives us a problem. That's where it's not continuous.
Okay.
And at what points is the function continuous? Well, every other point. In other words, continuity is a lot like domain. You pretty much try to figure out domain by figuring out what x cannot be, right? In other words, it's easier to figure out domain by figuring out what x cannot be rather than by figuring out what it can be. Well, if I look at this function, x can be anything except 2. That is the only thing that gives any problems at all. So it's continuous everywhere else, from negative infinity to positive infinity, except at 2.
Okay.
About 14.
So that's squared at the end.
What makes that denominator 0?
-2.
Yep, that's it. That's the only problem. And if x is -2, I'm dividing by 0. The square is actually irrelevant here. Doesn't matter. 15. Let's do 15 and then we'll be done. X plus 1 in the numerator. X squared minus 4x plus 3 in the denominator. When you see a quadratic in math, know that you almost always have to factor it. How does that factor?
X minus 4 and x plus 1.
X minus 3, x minus 1. Notice that if I split it up into these two and multiply it together, I get that.
Yes.
So now there's 2 spots that give you problems, which means there's 2 vertical asymptotes. Where are they?
3 and 1.
That's it. That's all. Usually when you're dealing with continuity, it's figuring out where the denominator is 0. Okay. There's a few other situations. In other words, if I say y equals square root of x, well, what's that look like? That looks like this. So that's continuous for what?
What do you mean?
Well, the question is, at what points is the function continuous? Well, I've just given you a function.
Infinity.
What's that?
0 to infinity.
Exactly, 0 to infinity. It's not continuous less than 0. So half of the number line is eliminated from the answer just because we're taking the square root of a number. You can only take square root of positive numbers.
Okay.
Okay? You good to go, or do you need to do one of these trig functions also?
I'll be good. Thank you, though.
You want to do 19?
If that's fine with you, that'd be perfect.
19 is not continuous at what value for x?
Cosine of x over x. 0?
Correct. That's the only number. In other words, you can take the cosine of any number. If it was just the numerator, then it would be continuous from all real numbers, negative infinity to positive infinity. But because we're dividing it by x, well, you can never divide by 0. So x cannot be 0. In number 20, notice that x cannot be pi over 2, 90 degrees. Because if x were pi over 2, I would be dividing by 0.
True.
Cosine of pi over 2 is 0. It's not, in other words, the answer is not x can be 0 because the cosine of 0 is 1. So there's no problems at all on number 20 with x being 0. It just can't be 1 because the cosine of 1 is 0.
Okay.
So that's the main thing to remember is you cannot divide by 0, you can't take the square roots of negative numbers, things like that.
Okay. Thank you for everything, Mr. Callan.
Talk to you next time. Bye-bye.
Okay. Thank you.